This is the CREATE Consortium, which stands for Embedding Advanced Urban Material Stock Methods within Governance Processes to Enable Circular Economy and City Resilience. This is the final project meeting that is taking place currently in Vienna in Austria. And we started yesterday, we will continue until tomorrow. And this is the final project meeting of the project that lasts for 3 years. The consortium, as you can see, besides Chalmers University of Technology in Sweden, we have the Austrian Institute of Technology, who is hosting us in Austria today, Wageningen University Research in the Netherlands, BRGM from France, Citésource from France as well, the Municipality of Nijmegen, Gothenburg City and Brasov Metropolitan Agency for Sustainable Development, what we called our need owners that we supported in this project. So the key areas of the project are the identification of circular economy needs and method specification. So what we did in the last 3 years, we had a couple of interviews with different relevant stakeholders within different cities all around Europe to understand the circular economy needs. Then we worked on a lot of co-dissemination with the stakeholders. We tried to develop tools that are tailored to these identified demands. Then we worked on data gathering and a visualization tool prototype that my colleague Maud Lanau will present in a second. Then we worked on co-creation, circular economy and governance arrangements that has been mainly taken care of our colleagues from the University in Wageningen. And then an impact assessment and evaluation of circular economy, which was led by the colleagues in Austria, AIT. So just to start, give you an overview about the visualization tool. This is what we call a digital resource cadaster. So we provide an overview of material stocks in the different cities and case studies that we have worked with, and this on a building and component level. We have 4 urban living labs that we have worked with, the city of Gothenburg, Vienna, Rennes Metropole, and Nijmegen. The inventory data includes building information. Maud will talk about it more in detail later, material quantities, and also material recycling and reusing estimates. Then we have also results from circular economy governance. This was done in collaboration with Nijmegen Arnhem in the Hazelport Urban Project, which served as a case study for local tendering processes. And you see the information here about the high ambition circularity objective that should be achieved in this project. You find more information on the different bits and pieces and the outcomes of the CREATE project on our project website as well. Then the impact assessment using circular economy and using LCA that has been worked on here, driven by AIT, where an assessment has been done about the circular economy strategies on the different case studies and the related environmental impact assessment. So what have really been the reduced environmental impacts or the effects of circular economy strategies that have been implemented? And now I'm happy to hand over to my colleague Maud Lanau to talk about the CREATE tool and demonstrate it.
Thank you, Holger. Good morning, everybody. So here is a little bit of demonstration of the tool Holger has been talking about. First, I would like to start with a few functionalities of the tool itself. So as you will see, so this is a digital resource cadaster. And I will show you that you can, using it, select different areas of the city, and there are many different filtering options to really refine your search. There is quite some visualization also of results, as well as tables that can be exported with data, and some estimation of material recycling and reusing. A few things before I start, just so that you may follow easily. In Gothenburg, you will see that we have results that are quite disaggregated, with results across sharing layers of a building. So whether it is whether the material is in the structure or the skin of the building, which is the envelope of the building, or the space like partition walls and so on. We also have the results across building elements for Gothenburg. For Vienna, results are a bit more aggregated. However, Vienna has been looking at more building types than in Gothenburg. So Vienna includes residential buildings, commercial ones, and industrial ones. And finally, I just want to mention that we also have done this work for the Rennes Métropole, but we cannot present it here because of data privacy issue. Okay, so this is a video pre-recorded in case internet would be difficult. So this is the Create tool, and in here you can log in, and you have a password to sign in, and you are ending up on the dashboard of the tool, and you can set up your user profile up right here. So name, family name, a picture if you like, email information, etc. Now, to create a project, you simply click on Create a Project. And here we see that we have 4 cities so far in the Create tool. At the top, you see that we have Gothenburg, and at the bottom, we have Vienna. And in the middle, we have Luxembourg and Tallinn. And this is just to demonstrate that we can add additional cities in the tool. Right now, we use the EUBUCO data to do that with dummy data. Okay, so now let's create a new project. And we have a dashboard. On the left side of the dashboard, you will see a number of filters. In the middle is a material cadaster, and in the top is a result section that I will show you later on. You also have a little information on how to use the map, if you wonder how, including how to draw areas on it. And finally, a color legend to know how much material stock we are talking about in the city. So for example, this building here is very dark red. And when we look at it, we see that we have about 15,000 tons of material stocked in it. And we can compare this to maybe a lighter red building here with only 260 tons of materials. Good, so zooming out, we can also now select specific area in the building. There is a tool for that. You take this little square up left of the map, and you can draw around the area that you want to focus on, like shown here. There. And you can still decide if you want to show the buildings outside the area or not. Here, remove them for clarity. And then you can also use time filters. So we have data in a good chunk of the data includes construction year, renovation year, and demolition year. So we can filter our data according to that. So here I'm filtering from 1890 to 1925 construction year. And you can see that the construction year fits here. 1910 is in between those years. We can also look at demolition year, for example. Now, one thing to note here is that this is modeled years. We do not have the data yet on when buildings will be demolished. And the idea with Create is that in the future, actors can put in this data so that we have really refined data on this. Same goes with renovation year. We have a bit of information on past renovation years, but we have assumed incoming renovation years. And here again, we want construction actors to input this data. So now I'm going to just select older buildings in Gothenburg here. And here you can choose the type of building. So as I mentioned before, we only have residential buildings here. And you can also choose the owner of the buildings. And before I go forward, I want to just mention that we added this section on owners of the buildings because many stakeholders have told us that this is very important information for them to go forward with the circular economy. We haven't included this in the tool because of, again, data privacy issues, but this is something we want to look into in the future. Okay, so moving on to the result. You can see the function that is a heat map that you have seen also in the communication material we have out there. And the heat map shows you where most of the material is stocked. And you have your results in terms of materials. You can see all of the construction materials across the graph up there, from bricks to concrete and polymer and whatnot. So here we have the address at the bottom. And you can look into each building and look at which material is in there. And you have the results also in terms of volume, not only mass, which can be also very informative. Finally, results here can be seen as table, and you can export that and just have an Excel file, and you can play around with these results if you want to do some more things with it. Now, the results can be filtered according to materials. So for example, here we see how much concrete we have in the buildings. And this filtering also works on the map. Now, if we compare here between concrete and brick, we can see that only a few buildings in the center of Gothenburg have bricks. And this is because many buildings in Gothenburg are made of wood. So at the city scale, we can also see very different distribution of material in the city. We can also look at the results, as I said before, according to building layers. So where in the buildings are the materials? So here we can see, for example, how much material we have in the envelope of the building, in the space, etc. And finally, we can see results across elements. So our materials in the ceiling, in the external wall, in the roof, in windows, and so on. And we can mix and match all of these filters to really try and understand, for example, the materials in foundations and roof, how much of it is in the structure, and how much of it might be, for example, in the skin. And here, logically, in the skin, we see that we have no foundation in the envelope of the building, only in the roof. Now, looking at wood, we can see that we have wood in many different elements of the building stock, as compared to, for example, glass, that will only show up, obviously, in windows in the building. So this works quite well, and this allows a little bit more refined investigation, though we still work with averages here. Now is for the resource cadaster of Vienna. So here I'm opening an existing project with the Vienna Resource Cadaster. As you see, it's a specific neighborhood that was looked into in Vienna, a quite big neighborhood, but not the entire city is mapped yet, since the living lab was around this area. So we can go around and look at all the buildings. Here again, we can select a specific area that we want to look at. Like this, and zoom into it. Again, we can show buildings outside the area if we want. We also have time filters here for those buildings that have the data, so we can select specific construction years. Again, we have the ownership here, although it's not yet included. We plan to work on this, and we have all of the materials, construction materials. So as I mentioned before, Vienna doesn't have the desegregation into layer and elements. However, Vienna has many different, many more building types, with not only residential, but also all commercial buildings and industrial buildings here. And we can select across different types of buildings, which can be very useful since different buildings has very different lifetime and will free up material at different rates. So here again, we can see the results in terms of chart, and we can export the chart, export the table, sorry. And finally, a last thing I want to talk about is a secondary waste management. So we have here again included this differentiation between what will happen to the material. And here we again have dummy values with about 10% being, I think, going to waste. But the idea here is that we can understand better how much material will be reused and recycled in the future to inform waste management. And I think that was it for the tool. I hope this was clear enough, and we welcome any question in the chat. And now is the turn of Ernst, my colleague, who will talk a bit more of data flows that went on to create all of these tools.
Thank you, Maud, for the presentation. My name is Ernst Gebetsritter from Austrian Institute of Technology, and as already mentioned, I will talk about the data flows, the workflow and the update, which is very important. So Maud presented the front end, but as you know, also the data is very important. And we had some frame conditions which were very important to develop. So for example, the data generation and that should be very structured and replicable. So in different cities in Europe should be available to use the tool and the data. The data should be based on the local context because each city has different local needs and the context, but however, in the end should be also comparable. As you have seen in the tool, many of the materials like concrete, they are then in the end the same. The next, the data and the data integration workflows should be documented and replicable. So it's very important also for the externals to understand exactly what the data means, how it is created and the workflows. Then the next, the data sources needs to be protected if non-public data is used as you will see in the next slides, we have also non-public data and we have to be careful how we use them and has to be protected. So there is a user management in the front end in the WebGIS tool with different roles. And then you have also an update of the user interface according to the roles you have. And last but not least in this list is we have to connect to existing systems, for example, digital twins, which already exist in cities. And all in all, when we work with cities, we often get the feedback, okay, another project, another tool is created, and then data for the tool is created, and we might have the problem to need another research project, which is 2 to 3 years to generate the same data. So therefore, this data workflow should give you an impression how we think that this is then in the end capable for the future in our project with our tool. So I will now present the data workflow Vienna as an example. What you see here, we once used also the Inspire building data sources because of the comparability that we have a unique identifier of the buildings in entire Europe in the cities where these buildings are available. For Vienna, for example, you can download these buildings, but additionally to this, we also use local data, and in green, you see the public local data, which is available. For example, in Vienna, there is a very good local data about the building footprints, which we used, where we get information also about building heights. But there's some information missing, for example, about the ages of the buildings when they have been constructed or refurbished, or other information like other residential buildings, whatever. So we used here a non-public data we got from the city of Vienna, from the MA20, where we have seen this also in the presentation before, the area you have seen for Vienna. And for this, we then calculated with some very specific material intensity data, which was from a study done by a professor at the Technical University in Vienna several years ago. And all of this information has been combined. And what is important, we also developed some scripts to do this combination of the different data sources in a way that it's more or less automatically. In this case, for Vienna, we used an R script. And in the end, this enables us to do conversion, which are needed from the different databases to convert, for example, the age ranges of the buildings to what we need, for example, according to the study of Lederer, then also the use categories and to calculate the building height from, for example, this local data source of Vienna. to have the volumes, which are important for this case in Vienna. And then in the end, we calculated on the building level these material intensities and created also automatically output files, in this case, GeoJSON files, which then can be uploaded to the tool, to the front-end, what you have seen. So this is the process we did, for example, in Vienna and in Gothenburg. You will see it's quite similar. What is important that you have several points in this data workflow where updates can be. There can be updates in the Inspire building database or in this additional data what we have, for example, the scale set data from the city of Vienna. It's available for the entire city. We just got it for a smaller area for our project, and thanks for this. And also this FMKZ layer is regularly updated. So every few years you have new data sets. This is the most appropriate data set we can use in this case. And this intensity study, which I mentioned already, this is quite old, and we know that this has some problems and there might be in the future better values, and all this can be updated. And according to the scripts, the processing of a new data is quite simple. So what is important, what you also see on this screen, the other possibilities, because you know the data quality is one of the most important things. And as I already mentioned, we know that we have in all of these source data some problems. So what can we do? And you see on this screen, there's a dashed error. So the use of the tool could also help us to update this. For example, if there's a possibility that user of the tool can add their data, for example, if there are refurbishment projects and there are better data about what you got out of these buildings, it could be then added if you have the permission to the tool. And then in the end, it could help us, for example, to get a better idea about certain specific parameters for residential buildings of 1945. So this is an important possibility the tool can also have in the future to update the values in the tool and also make it better because of the use of the people who use the tool. The next is the documentation. What we also developed, we developed the documentation which is online, so outside of the tool. And this is also a web-based documentation, meaning it can also be connected to the different parts of the tool. As we already have heard, we have the different cities, and in the different cities, we have different things what we can show. And this thing needs to be documented. And it can be connected to the different parts of the tool. This also can be easily integrated, for example, with video tutorials to guide the people to use the tool. Thanks. So this is also very important that this is something we constantly further develop, the online documentation for the tool. This, for example, is then the workflow for Gothenburg, which you see it looks quite similar. We have some public, non-public and specific literature we use, and also some procedures more or less automatically then to create this classification, and also then the important data sets which should be uploaded, imported to the tool.
So now we move to the next part of the meeting. So we wanted to present you some of the key results of the project. And so I will present you an overview of the result of one of the first work packages of the project, which was about better understanding what the cities that we were working with were doing already, and so how they would like to go further. So in terms of data, about flows and stocks of materials in buildings, and so we work closely with 3 living labs, so Rennes Métropole in France, Göteborg in Sweden, and Nijmegen in the Netherlands. And there was some further work with Vienna in Austria that was carried on, but later, and not integrated in this work package. So we did a few interviews, we did some literature reviews, so there's an article that's going to be published soon, this year maybe. And we also did some online questionnaires, so we got a few answers from people working in those 3 cities, not only the working within the cities, within the municipalities, but also architects or urban planners, for example. And so I will just present you some brief results, but that work was later developed in another work package of the project that we're not going to be present today, which is the first one, and it was led by Wageningen University Research, and they go more further into analyzing those practices and also into proposing some recommendations for the city representatives. So there you can see a summary of the key results that we could get in this work package. So we could see that there are common practices and needs for those three authorities. We could see that all of them were already working on circular economy. They already had some actions and some plan that was more or less formalized, but it was already there. They all performed some life cycle assessments for new buildings. So there's a focus on life cycle approach, but only for buildings. Also the criteria of CO2 emissions, which is very important. And also one last point is that we could see that there are multiple barriers, not only about data, but there are very different ones about cost, about the regulatory framework, which is different in each country, but data is not the only barrier. There are others. So this is important for this project. And then you can see some specificities. So each city had its own story, we can say. So, for example, Rennes Métropole already carried on a full metabolism study before the CREATE project started, and so the flows and the stocks in all the metropolitan area were already assessed, and there is also a focus on 6 urban projects, and so that helped the city to formalize its strategy. And so now they have a strategy which includes some objective related to sobriety, so reducing the consumption, not only working better on reuse or recycling, but also how they can reduce the consumption of materials, because that was one of the key results of the study, that the needs for materials is much higher than what we could get from reuse or recycling. They also promoted some physical reuse platform, which now exists in this city. And so what they wanted from such a tool as the one we developed was rather to focus on urban projects, not only on entire city, and to better be able to include circular economic criteria in the decision making at the very beginning of the urban projects. That's something that we try to do with them later in the project. Göteborg had another story. So with the help of Chalmers, they already had a full study on the stocks in residential buildings. They have very specific data which are available in Sweden from building permits, which is not the case in other countries. There is a very special stakeholder which is Framtiden, and they own a lot of the residential buildings in the city, so they have some special means to act on those buildings. They have a networks, and so they had some need for the tool that was more at the city level, but each building in the city. And Nijmegen had again another story, so that they already had a tool that was based on life cycle approach, and they have a tool to assess circular economy in every new building that they tested at this time. So they had a different need, which is more about to understand what is the impact of each new construction on the entire city. So we can see that the practices and the needs of the 3 cities that we studied were very different. So that's something that is important to take into account. I think it's important to when you think about producing data on stocks and flows of materials and visualization of these data, it's important to take into account the context of the city and to try to develop a solution which is specific to each city. That's somehow what we did, as was shown about the CREATE tool, that the data structure is adapted to each data that is available, for example. Very important to take into account the stakeholders, the skills which are already present in the city, and how we can better use the research institutes, for example, and develop something based on those people. So the governance issues is very important. Also, there's the question of the privacy of data that we mentioned. It's not only the problem of producing data, but can we share this data and how can privacy can be respected? And what we can see is that these all topics of circular economy, and in particular in the construction sector, is very new. So there is a learning, a culture-action process, which is very important. And so it takes time, and it's normal to test solution and then to adapt, so that there's not one solution that could come from one shot only. It's something that's more a process to improve later and later. And so finally, you can see some links of some of the deliverables of this work package, and so you can find those documents online to read it later. Thank you. Now we'll hand over to Sophia, who will present some results about life cycle assessment.
Thank you very much. I just took a closer look at the results from the Mentimeter, and the question for what purpose you would use this tool for. Many answers were CO2 equivalent estimation, waste management, resources, and life cycle assessment. And I'm super happy that I can present that to you now, because that was the task of AIT. So the impact assessment and evaluation of circular economy on 3 different use cases. The co-creation process within with the stakeholders of the urban living labs, as we call them, so the cities Rennes, Göteborg, and Vienna, has been a co-creation process with a scenario development, the usage of different lifecycle assessment tools, where we in the end have chosen OpenLCA with the EcoInvent database as our main tool to have an impact assessment of the circular economy aspects, and this especially in terms of a KPI-based one, so primary material and energy saving, CO2 emission reduction, and other impacts. The 3 urban living labs, as I mentioned before, do have the same underlying methodology, the same tools used, as well as the same functional units, but they differ in focus and scenarios. So for example, in the Viennese use case, we have new buildings in Aspern-Seestadt with 4 different LCA scenarios, as well as for Göteborg and Rennes, we have an end-of-life to second life approach. So material reuse, recycling from either nearby demolitions or the recycling of material and the reuse on the same building site or plot. The scenarios do differ between a business as usual or a build as usual and a circular economy approach, whereas in Vienna we have 1 sustainability and 2 circular economy scenarios calculated. We can see that those modules, as it is in life cycle assessment that we took a closer look at. For a Viennese case, we do start with the manufacturing of different products, transport, the assembly on site, as well as the replacement. And we do consider the end of life of such buildings and the possible reuse or recycling at the end of life. In Sweden and in France, we did have this end-of-life to second life approach, where we start with a demolition, see which benefits could be included into the new construction, and how the life cycle assessment did work out, and those different KPIs that you see in the very bottom, demolition, new buildings, primary resources, secondary, as well as energy, in this case, primary energy of non-renewable totals, the CO2 equivalent, the recyclability of materials, and the acidification. When we look at the Rennes metropole scenarios, we do see that the material outflow, so whatever is being demolished, is the same as well as the inflow. The materials that we did assess in this is mainly concrete, aggregates, as well as brick and bituminous material. So, and we see the new buildings do exceed the demolition But in virgin material, in the comparison from the build as usual to the circular economy scenario, we see a decrease in virgin material and an increase in secondary material. The global warming potential total, as well as the primary energy and all the other indicators, did perform better in the circular economy scenario than in the build as usual scenario. The same applies for the other urban living labs. So in the Vienna scenarios, we had 4 different scenarios that have been calculated, and you can see the different materials on the very right side. So one of the main conclusions is that in every scenario, whether it be the circular economy scenario 1 or the circular economy scenario 2, so every use case did perform better in those than the build as usual. And there can also be an assessment whether it may be you want to focus on the global warming potential, or one of your main aspects might be the virgin material or the material for recycling that could be possibly recycled at the end of life of the building. So maybe from I don't know how much time I have left. So now I'm done. That is Göteborg performs very well as the others did. And maybe just one last word in terms of the takeaway. Vienna has a broad scenario testing and the precision, and was a very material specific strategy. The best circularity did perform in Göteborg, and the maximum net energy gain in these scenarios. And one of the main takeaways from the Rennes use case was this practical site-based recycling and an improved material balance. Thank you very much. And now I can hand over to Holger.
So thank you very much, Sophia, and to the other colleagues for presenting. So now it's up to me to share with you a few conclusions and limitations. So what you have hopefully seen and might also read on the website and the other project outcomes that has been disseminated and produced, that we worked on the development of a visualization tool to support recycling and reuse of existing stocks of buildings in Gothenburg, in Rennes Metropole and Vienna. We worked also on the implementation of circular criteria into a tendering procedure for construction processes here for the municipality of Nijmegen, and the identification of best practices for decision support for all the other urban living labs as well. There was a governance analysis context to the urban living labs, and to define policy recommendations for forward-looking really procedures for realizing circular built environment in the municipalities. And last but not least, as presented by Sophia at the very end, an assessment of LCA impacts on circular economy implementation in these urban living labs to really see what are environmental impacts on specific case studies. So this is in a nutshell from us.